is your teacher Hayes, and for today's topic, we will discuss what is index of determination, or the R squared. So now, we will dive into the new topic, which is the index of determination. But before that, let me read first the learning objectives. So by the end of the lesson, the learner should be able to define the index of determination, or the R squared, identify the components of score variation, which are the SST, SSR, and SSE, compute R squared using sample data, and interpret R squared in the context of assessment and prediction. Let us recall our previous topic. So we talked about reliability, right? Which refers to the consistency of assessment results. So it helps us understand the assessment tool, whether nag-produce ba siya og stable result over time. And our topic today is closely related because it deals on how well one test predicts another. Okay, to start with, think about this simple question. So if you performed well in the diagnostic test at the beginning of the semester, would you expect to perform well in the final test? Okay, so most of you would probably say yes, and that exactly index of determination help us to measure. So index of determination, or the R squared, is derived from the correlation. It tells us the percentage of variation in one set of scores explained by another score. So in educational assessment, it helps determine whether one test is a good predictor of performance in another. So for example, the pre-test score and the post-test score of the students. So if the R squared is 0.60, means 60% of student performance in post-test can be explained by their pre-test scores. So to better understand R squared, we need to know that all scores have variation. So the total variation in the final test results is called SST, or the total variation. So it shows how spread out all the final exam results. So SST is divided into two parts. We have the SSR and the SSE. So when you say SSR, this is the explained variation. So it tells how much of the total variation can be explained or predicted by the diagnostic scores, or the X. So if the SSR is large, it means CX, or the diagnostic scores, is a strong predictor of the final scores. And the the second part is the SSE. This is the unexplained variation. So it represents the part of the student's final test score, or the Y, that cannot be predicted by their diagnostic scores. So if the SSE, or the unexplained variation, is large, it means si diagnostic scores is a weak predictor of the final scores. So now, let us look at our sample computation. So visible or ba ninyo ang data? Yes, visible or ba ninyo, class? Okay. So we have here the sample data, right? We have the student. We have 5 students. We have also the scores, the diagnostic scores, and the final scores, the X and Y. So we have here the diagnostic scores, right? We have 15, 18, 12, 20, and 10, and the final scores 20, 23, 17, 25, and 14. So here we have our step 1. We need to compute the means. So we have to kuhaon na to ang summation ni X and summation ni Y. So we need to add total scores ni Y and total scores also ni X. Okay, so we have 15 plus 18 plus 12 plus 20 and plus 10 equals 75, and we need to divide it kung pila ang total number of students. So divide 5. Also sa Y pod, same process. 20 plus 23 plus 17 plus 25 plus 14 equals 99. Divide it total number sa students. So we have 75 divided by 5, we have 15. So our mean sa X is 15, and we have also 99 divided by 5 for our Y, 19.8. So now let's proceed to our step 2, which is the table for deviation and product. So visible or ba ninyo ang table, class? So we have our table na atay X, atay Y, X squared, Y squared, and XY. So for our X, we need to sum up all the X. Summation of X, we have 75. Summation of Y, we have 99. And for the X squared, atong squared ang tagsa-tagsa ka mga X. So for example, 15 squared 18 squared, 12 squared, 20 squared, 10 squared. So, summation of x squared, we have 1193. And for the summation of y squared, we have 2039. And for the summation of xy, we need to multiply the x sa y. So, we have the total 1,558. So, for our step 3, ani na, mag-use sa formula which is ang tong percent correlation. So, we all know that, guys, the percent R formula, diba? So, we have the R equals N, open parenthesis, the summation of xy, close parenthesis, minus, open parenthesis, summation of x times summation of y, over, we have the square root, then open bracket, the N, N times summation of x squared minus open parenthesis summation of x then squared close parenthesis n times summation of y squared minus open parenthesis summation of y then squared. And now we need to substitute ani nga mga number to compute sa ato ang correlation. So here we have our numerator, we have 5 times 1558 which is atong summation of xy minus open parenthesis 75 times 90. We have 7,790. 5 times 1,558 equals 7,790. Then 75 times 90, we have 7,425. So equals 365. So let's proceed sa atong denominator. We have square root, open bracket, 5 times 1,193 minus 75 squared, close bracket, then open bracket, 5 times 2,039 minus 99 squared. So we have the total 5,965 minus 5,625 times 10,195 minus 9,801. So we have here the square root. We have 5,965 minus 5,625 equals 340 times 10,195 minus 9,801. We have 394. So we have here a total 340 times 394 equals to 33,960. So ang square root ani is 366.01. Finally, compute R. We have R equals 365 divided by 366.01. So we have 0.9972. So for our step 4, pauda na to ang index of determination. So the formula of index of determination is R squared equals R squared. So using our correlated computation, which is the R equals 0.9972, R squared equals i-open parenthesis, then isulod ang atong computed correlated correlation. We have 0.9972 squared. Our answer is 0.9944. So this means 99.44% of the variation of the final score is explained by diagnostic scores. So this is an extremely strong prediction. To sum up, class, knowing R squared or the index of determination allows teachers first to evaluate the usefulness of diagnostic tests to see if they truly predict the student performance. The second one, ensure fairness so the students are assessed more accurately. Third, guide instructions and remediation. So, plan lessons or extra support based on prediction outcomes. And the last is make data-driven decision. So, rely on evidence rather than just assumption. So, for your assessment class, I put the kanang sample data in the PPT. And I want to know whether the midterm exam predicts the final score of 8 students. So, you need to compute the correlation coefficient or the R, then calculate R squared using the formula. So I hope you learned something and do your assessments as your homework. Thank you, class!